Recording. Okay. So we're going to talk about dimples and why we do dimples. So I've drawn one layer, the white layer underneath the blue layer. The blue layer is our sacrificial layer. Okay. It's our silicon dioxide. So we want to make a dimple, and I'll explain why in a few minutes. But what is a dimple cut? Well, basically what ends up happening with the dimple is you end up getting rid of some of the silicon dioxide, but not all of it. Okay, and so why do you do that is if you deposit polysilicon on top, you get a structure that looks like this on the side view. Okay, so you have this gap here, right here, after you remove the silicon dioxide. So why would you want a little gap here? Well, when this thing bends down later on, this structure, if you don't have a dimple, this whole structure here will mesh with this structure here, and you have to have two materials that are similar and very flat, and they come into contact, they stick. You can't get them apart. Okay? So the dimple's there to give you a smaller surface area, so the springiness of this poly structure will keep it from sticking, because you don't have enough surface area for the stiction to be a strong force. Okay? So that's why we make dimples, to keep things from sticking. All right. So let's back up a little bit. Let's get rid of the poly. Let's pretend we haven't put the poly down yet. Okay, so we made a dimple. Now the next thing we're going to do is we're going to make an anchor. So this time we're going to cut all the way through. Okay? So remember, whenever we make holes into things, we put the photoresist down. We put the holes in the photoresist where we want the holes in the stuff underneath. So we put a hole in the photoresist over here, but we didn't put a hole here, so we protected that when we made this anchor hole. Does that make sense? Yeah? And now if I put my poly in, I'm going to make an anchor. So now that part's connected, and I'm going to have a dimple.
Okay. All right, and so the dimple, you had a different mask and you didn't etch it as long.
Yeah, you didn't etch it all the way through. Now at Sandia, they etch it all the way through, and then they put a little more silicon dioxide in there to fill it back up, but only partially. Mm-hmm. And that's how they make their dimples. And then you can, and the reason they do it that way is you can control this height very, very well with deposition. It's really hard to control this thickness with etching. And we can talk, half an hour on that alone if you want.
They make the dimple on the other layer.
Yeah, the dimple is on the layer underneath where they deposit.
Right.
And then when you deposit the poly, it fills in the dimple and gives you this bump on the bottom.
Right, so it doesn't stick.
Yeah, and then then you pattern your poly zero, so you get rid of, you make your cantilever the length you want, and then you might make some release holes in it with that whole mask. What's interesting about the whole mask for poly, you actually draw it in two layers. You draw the holes and you draw the poly, but you make one mask. So they combine the two layers and they spit out one mask. Because it's really hard to draw holes with polygons. They used to do it that way. So now they come up with a software solution. You draw a bunch of holes, you draw your structures, and you overlap the two, and then you spit out one mask. Okay?
Yep.
So that's all there is about dimples. And why do we care? Well, when we start to do the release process in liquid, it will start to dissolve like this, right? So remember, this right here This interface, this is liquid, right?
Mm-hmm.
This is a solid. So we're dissolving, right, into a liquid. And this is all liquid up here. Okay, so I'm going to keep dissolving. And I'm dissolving, dissolving. Okay. And what happens is you get a liquid in here, a meniscus. A meniscus has surface tension. Liquids have surface tension. It's going to want to pull the cantilever down. There's going to be a force because of the meniscus. Why am I not getting? Oh. There's going to be a force pulling this down because of this meniscus here. So if I blow this up, the meniscus, surface tension of the liquid is like this. Okay? Actually, I misspoke a little bit. Let's repeat that a little. We etch all this out, and this is all liquid, right?
Mm-hmm.
So when we etch it all out, we still have liquid in there. Then when we dry the liquid, it'll dry from the end and work its way in.
Mm-hmm.
So you get to a point where this is air,
Mm-hmm.
and this is liquid.
Mm-hmm.
And that's when the surface tension starts to pull it in. So it'll start to pull this thing down. And if you have a regular cantilever without a dimple, you know, here's your anchor.
It's just going to stick and
It's going to go like this, right? And then this is the other layer underneath. Redraw this. Okay, and you've got all of this surface area here, you know, a huge amount of surface area here. It's going to stay stuck.
Mm-hmm.
And polycrystalline silicon's pretty flexible when it's thin. When it's thick, it's like brittle, but when it's thin, it flexes a lot and it'll stick there.
Mm-hmm.
Okay, but if we have a dimple on it, okay, instead, right, it's going to want to come down, but you got this dimple stopping it, don't you? So that meniscus is trying to pull this thing down, okay, but it hits the dimple. And that's a really small surface area, so that it won't stay stuck. Once you dry away the liquid, it's going to pop back up again. You won't have that meniscus force anymore. The stiction force is small because it's only at one point, and so the cantilever will break loose, and it'll be free to move. Okay?